Who here enjoys deploying production changes late night, last minute on a Friday night? Well, you really shouldn't. I certainly don't, and neither does my team. So we had to break some rules to be able to join you here at the Dev Summit, to be able to release our progressive web app just in time. So hello, my name is Andrew, and I work for a company called Konga, and I'm here today to tell you a little bit more about our new progressive web app, Konga Easy. So let me find my clicker. So what is Konga? So Konga is an online shopping website in Nigeria, a leading one, and we have a product catalog consisting of products from our marketplace. So we have our merchant partners who manage and upload and manage inventory and orders, etc., in a separate system. And so it's consisting of marketplace products and retail products, our own in-house retail products. So we currently operate in Nigeria, but our mission is actually to become the engine of trade and commerce in Africa as a whole. That's our mission statement. So we have teams based in Lagos, Nigeria, and in Cape Town, South Africa. And the main reason I enjoy working at Konga is that through business service and technology, we actually make a difference to people's lives, we add value, and we can see these changes on a relatively easy scale. So we offer support to SMEs and provide a wider selection of products to consumers and customers, and we're actively making a difference to these people. There's not a large amount of brick-and-mortar shops, so for consumers to be able to have access to this product selection makes a difference. I would like to extend a serious thank you to the awesome team of technologists based in Cape Town in Nigeria, and I'm extremely proud of the work that they've done over the last couple of weeks. It's been an extremely short period of time, and I'd like to say a big thank you to them. So I'm going to tell you a little bit about the Nigerian market and the network infrastructure there. It's not normal, not simple. There's about 185 million people in Nigeria, and of that number, about 100 million internet users. And this is a difficult number to manage because Nigerians are known for multi-SIMming, so they'll have multiple SIM cards. And the reason for doing that is because the telcos, the telecommunication companies, have varying rates and varying network coverage. So that's probably not a very unique number. But of that, we have a high mobile penetration, 80%. And here's an interesting stat, that 65 or 64% of all traffic in this area is being served on 2G, and actually about 15% is being served on the edge network, and which leaves a remaining 20% that's being served over Wi-Fi and 3G. So you can see this is relatively problematic, and I'll explain why in a moment. So Nigerians, fantastic people, they're particularly price sensitive, so they're willing to sacrifice almost any other aspect of a product over price. And this is a source from McKinsey. So besides being price sensitive, this obviously relates to being data sensitive. And obviously there's an associated cost with data. And these numbers are not particularly correct. I'm just trying to paint a picture here, so don't quote me on these numbers. But imagine if the minimum wage in Nigeria, about 18,000 naira, or more or less $100 US per month, and imagine the cost per megabyte of data, and I've said here it's 0.5, but I know it's actually it is coming down, and I look forward to it reducing even further. But the picture I'm trying to paint here is the fact that there's a non-negligible amount, a significant percentage of that monthly wage could be spent on downloading our app. And this is something we would like to mitigate. So we also have mobile traffic, very strong mobile traffic, iOS and Android apps. So besides that, if you just look at our web traffic, and we have a responsive web application, our current traffic is sitting at about 60% mobile, or mobile web, and about 5% tablet, and the remaining is desktop. So you can see our customer base is actually quite focused on mobile web. So, why progressive web apps? I think it's actually quite simple. It's actually really, really well suited to our use case. So right now, and traditionally, we've had about 3.5 years of operation, and in that time, we've built a responsive web design, a responsive desktop application. And it works really well on Wi-Fi and 3G, as you'd imagine. But I guess if you look at 2G networks and the average transfer rate on our CDN, it's sitting at about 250 kilobits per second, which is obviously not ideal if you're trying to download a homepage for the first time and it sits at 2.5 megabytes. You can imagine how long this takes for our users. So that's the first area that pushed us into progressive web apps. The native apps, so one of the major problems is we're a startup and we're changing our business model pretty fast. So in these environments, it's very difficult to produce a native app and expect that to last the duration of our business model. So essentially, we're changing features all the time, and every time we make a change to these features or to these apps, we have to release a new version. And with this new version comes an upgrade cost, and our users they don't want to upgrade. Well, they don't want to spend 15 megabytes upgrading the app. So what we've ended up with, the result is a long list of versions that we can't really support, and the users refuse to upgrade. And then finally, these native apps are pretty much thin HTTP clients, so they do work under sort of degraded networks, but it's not really built with offline first in mind. So we could have gone an incremental route, or should we go from scratch? And it just happened to coincide with something else that's going on in our engineering department, which is a re-platforming. And so at this moment, we're actually breaking down our monolithic e-commerce application into a bunch of smaller, independently deployable, independently scalable microservices. So this is actually the focus of our engineering department at the moment. So we started with a complete mobile web redesign, so just a design optimization, and a lot of these improvements have come from this redesign phase, not only from progressive web app technology, but also from the fact that we looked at our design and said, okay, let's stop serving 800 kilobyte images to our users. So the focus was on clean and simple UI, as well as a slick customer experience, a user experience. So we designed features and applications as a whole with an offline-first approach. So we looked at a bunch of different areas of the application and decided to build this with an offline-first in mind. So we started with an app manifest. So that's the first thing we did when we moved to progressive web app, and it gives us the ability to add the app to home screen and to launch it in standalone mode. And then, as you can see here, we have a little coach mark and an action, a call to action. And then the next thing we did was added a service worker, and we use this as a network proxy, and it gives us control over the network layer. And we utilize the service worker to cache all resources and requests that come through it before it hits the network. And we use the fastest cache strategy. This ensures that our app content renders quickly and even during intermittent network connectivity or a completely degraded network. So those are the first two things. We added an app manifest and a service worker. The next part, we decided to use the application shell architecture to load all app static content and data on initial load. So we cache them, and then only after they've loaded, we render them to the user. So the app shell architecture consists of HTML, CSS, and all the JavaScript we require to bootstrap the site, excluding all the user data. So other than the app manifest splash screen, we also added our own splash screen that we basically show that until all of that content is loaded and then release that and render it to the user. So the other thing we've done with the app shell is we've vulcanized all of these components into a single file. So when the site loads, we load the entire file first before we render it. This process concatenates all custom elements into a single file. So all of our custom web components, as well as the Polymer components and third-party components, they're all compressed into one file. And something that we get out of it is very simply, we get some extra linting, some optimization, as well as the minification of our resources. The next part of our app journey was looking at the background sync API. So this really suits us well for analytics and tracking of offline actions. And there's another element to this that we're very interested in using, and that's the idea to provide some sort of offline checkout capability. So the problem with this is, imagine I'm offline and I'm looking at a product. How can I guarantee that that price and that stock quantity is available at the time that that background sync event happens and it sends an action to the server. We can't really guarantee that. So that's something we're working on. We're looking to innovate in this area and hopefully use background sync to provide a solid offline checkout experience. So with Polymer, we pretty much went with a bare bones approach. We avoided third-party libraries in order to reduce the app size and focus on speed. We chose to use plain JavaScript. I think it's quite common knowledge that plain JavaScript can outperform third-party libraries. So we didn't include jQuery or Angular or the like. So we also we ensured that we only declared properties that we used and tried to focus on reusing JavaScript functions where we could. So it's a pretty bare bones approach to Polymer. So some of the practices that we followed, we tended to use reusable web components, so we built some of our own custom elements. And the challenge that we had was when we had to fully define each element before we used them and control its scope. And we often found ourselves in situations where elements were being forced to be reused, but ended up performing different actions that they were initially intended for. So that's one of the areas that we struggled with. And then quite simply, we managed packages using NPM and dependencies with Bower. And we decided to lock down all of these dependencies to avoid introducing errors into our staging and production environments, and instead built those checks into our build process and sort of manually managed that dependency upgrade piece. Then another thing that we did was and we're still working on it, is a custom web component repository that we manage with Bower. And some of the pieces that we've figured out here, we hope to roll out to other areas of our applications and our systems. So hopefully we'll be able to use these web components across projects and manage that with Bower. So some of the major obstacles, I think we've all heard about some of the challenges supporting Safari, and I think we've made some really good progress. I'm not going to explain all of that today, but we will continue, and I think we'll probably get that right pretty soon. And so one of the largest things, one of the obstacles, I wouldn't really call it an obstacle, it's more like a challenge, is the learning curve of moving from normal web development to progressive web app sort of technology. But even more so, we had a resourcing issue. So all of our web developers are building certain projects at work, and the only team that was available at the time to look at this was our native engineering team. So these are experienced engineers, senior engineers, who've been working on iOS and Android for a long period of time. And I tasked them to build this progressive web app. So you can imagine their initial concerns. But I can say they led this engineering effort, and I'm very proud of what they've done, making a switch from compiled sort of native app environment to web development. And I think we've had a fantastic result come out of them. So well done to them. So we had some problems with modularity of web components. So you normally need to define a style for a specific component, and whether to do it for specific ones or global rules. So this is kind of something that we struggled with, and we're still working through, and I hope to figure it out over the next couple of weeks. And then finally, here's a swear word in our office at the moment, is cross-origin resource sharing. And I think some people would probably agree, if you're sharing resources across domains and across systems and different services, it becomes extremely problematic. So if I could make a suggestion to teams that have that shared domain within their systems, I'd probably spend quite a bit of time preparing to mitigate against this kind of thing. We always end up deploying something to production, or not to production, to staging, and it just doesn't work. And 9 times out of 10, it'll be a cause issue. And I'd like to explain more about obstacles that we faced during this journey, but the honest truth is the real obstacles we faced were internal ones, not really major obstacles moving towards progressive web app. And yeah. So, as I said, late Friday night deployments. We deployed our beta version this last Friday, just before I flew here. And this is a sneak peek. We decided not to release to all of our public. We're actually a very highly transactional website, and we didn't want to destroy all of our revenue at once. So what we did was we handpicked very specifically 50 users, and we're currently going through, I guess we can call it an A/B test. So we're just presenting this new web application to 50 of our customers, and we'll probably add more as we go, and we'll be gathering metrics and making changes as we understand more about the app and more about the users on the app. So it's live. So here's some of the initial results, which I'm extremely proud to present. And the reason why I'm so excited about it is because you can actually see this effect on our customers. And I wish I could explain more. I think you'd need to sit in some of our usability tests, and you'd understand. So I think one of the excerpts I'm taking from one of the usability tests I'd seen was a user, he'd searched for something on our website, and he'd seen a big list of an infinite scroll of products. And as he was scrolling through these products, he exclaimed, "I can't scroll like this, it's costing me too much money," which is a serious indication of how sensitive people are with regards to data. So the first thing that we achieved out of this is for the homepage, well, it's not very difficult if you think about that original image I showed you with 7 images in a slider, each at 800 kilobytes per image. So again, this is a large optimization came from a redesign, not only on Progressive Web App, but a big component of it is. So 92% less data on initial load, and most importantly, 82% less data to complete a first transaction. So the mindset is, I'm shopping on your site, it's costing me money to be able to check out on top of the actual order value. So I'm excited to be able to present this to our customers. It's not shopping for free, but at 82% less cost. So that's what it looks like. As you can see, I'm just showing you the previous design as opposed to our Konga Easy Progressive Web App. Very simple, very clean. It's like a before and after picture. And this is another before and after picture. It's not that we were actively looking at these metrics. I'm assuming that we will start to seriously look at these pieces, but I just happened to catch it before and afterwards, and I don't know why the page speed score went down. I'll have to go and investigate what happened there. But the page load time, and this is obviously sitting on a wired connection. I don't know where GTmetrix servers are, but they're obviously wired to get a 5.5 second homepage load time. And we've gone down to 1.2 seconds, and more importantly, a 2 megabyte homepage is now being served at 140 kilobytes. And as you can see, the 151 network requests have become 9. So this is something I'm excited about. And another area that we're preparing for, we didn't really struggle with migrating to HTTPS because we'd been preparing to go to HTTP2, which is a prerequisite. So at this point, this is something that we didn't struggle with, but I'd urge people to take that dive, specifically for some of the gains that are coming in HTTP2. So here I'm going to show you 5 major areas of the application that we focused on in terms of an offline first experience. And the first one is the catalog experience. So as you've seen in other applications, it's possible to just cache all of these requests and responses with service worker cache, or even in the IDB database. And so what you can see me doing here is browsing, and what happens when I switch off the network is a little pop-up comes up and it says, hey, you're offline, click here to be able to browse offline, and it takes you to our accounts section, and you can click on your recently viewed items and see all the products that you'd seen. So it's aggregating all of the catalog data that's been cached and representing it to the user. The second feature is our wish list. So we've depicted it as save for later. And the idea is that you've saved these products on your device, you surely should be able to view them at a later time. And you can just see me here switching off the network and being able to navigate to my wish list, to my saved items, so that I can shop even when the network is down. Or not shop, but at least continue to view these products. So can I have the audience raise their hands? Has anyone ever added any livestock to cart? Okay. Well, if you haven't added any livestock to cart, you can now come to Konga. And this is not an uncommon thing, actually. So I've personally done so and had livestock delivered with a bow tie delivered right to my doorstep. So I'm trying to show you three features here: cart, profile, and checkout. And what I'm trying to show you here is, I'll wait for it to move forward. But what I'm trying to show you is I'm in an online state. I'm searching for a live goat, and I'm presented with a response. Obviously, this is a search result, so I need to be online for that. I find my product, and let's imagine the network dies. And initially, I wouldn't be able to add to cart, specifically if it was an API call. But in this case, we've moved all of our logic client-side, and we're controlling the user experience and that entire journey on the client side. So I'm able to add to cart. In this case, add a goat to cart. And I'm able to continue viewing my cart, viewing all the price and the state of my cart in an offline mode. And right now, in this specific screen grab, I'm just showing you our current offline checkout. I have mentioned some changes that are coming to that checkout process. But instead of being able to check out, it sees I'm in an offline state, and it allows me just to call to order, and we have a team of customer experience representatives waiting for offline checkout. So what's next for Konga Easy? As I said, we're in a beta mode. We're currently collecting data and UX metrics, and hopefully, depending on what we find, we'll make a few more last-minute changes before releasing to the wider audience in Nigeria. We're going to continue to solidify our offline capabilities. I've shown you some features, and we're hoping to apply that approach to all of the components of the application. And then, as Owen said yesterday, we have started on our push implementation, but we're going to implement timely, precise, and relevant notifications quite shortly. The final part is obviously to continue supporting all browsers, and I'm very excited to see so many vendors here today, and I'm looking forward to being able to produce a consistent, progressive web application to all of our customers. Thank you.